Good morning. Good morning, everybody. Namaskar. This is Suraj Singh speaking from Bharat, India on this day, 28th February 2022, Monday. It's now 3:52 AM. मैं सूरज सिंह भारत इंडिया से बोल रहा हूँ। आज 28 फरवरी 2022 सोमवार सुबह के 3:53 and same talk about quality back to you in that regard. Important talk, and here is my email ID suraj_engineer@yahoo.co.uk, and of course this is title cover page of a book, Building Practice, and here is International Professional Engineer Certification, and this is Chartered Engineer Certification, and this is Fellow Membership Certification of IEI. This is Quality File, and this is Engineering Coordination File. All these are important for everybody. I close this file, and I close this file for time being. You can say construction importance, how to think on coordination. This book contains a lot, and same way we can say quality issue, and in title here you can see projects works which relate to quality issue, coordination world, communication, network, very important, same topics regarding, and we have to talk of quality in life, quality in products, quality in persons, individuals, quality in system, quality in nation, quality worldwide, conduct of people, and how to use products, should we rely on them. So many issues are concerned, are related. I'm talking of generality, and because I am from Bharat, India, I have to speak about this country and have to think a lot for all others. Quality and coordinations are required, but there is no meaning on that if you don't value it, and if you don't think it's something. We can say I close this file also. Coordination, engineering, and public engineers. What we have to say about this? We have to think of this in different manner. Samayana Abhintri, we call it in Hindi. Coordination engineering, we call projects, plans, and engineering, and public, general public. For reliability and quality engineering, cost delivery, they have to think of. And coordination engineering is one must. It's something undefined, but it's essential. Without coordination, nothing works. That's what you have to think of. Coordination of what we can see in building. What's coordination actually? In buildings, coordinations is one way. In the other plants is another way. There are systems, which you can say, of course, systems. You can say systems are different, works are different. In life, coordination. So you can say everywhere in life, coordination is one way. In profession, it's another way. In society, have difference, and we can generalize that if you think of that one. What is coordination engineering? We may say coordination, first we have to understand coordination, and then we can apply it in engineering. Although every talks, even a student in primary school coordinates, but we cannot recognize it. The student cannot understand it. Without coordination, nothing can be studied, Nothing can be studied. You cannot study anything if you don't coordinate properly. And that coordination is actually to keep your mind intact with some focus. If we focus our mind on some destiny or some, you can say, some object, to get that object, we have to link it to many other objects, to many other requirements of feedback, and only then we can say, right, it is now. For example, my body works, so naturally, of course, it's working. But there are many systems in my body. You can say multi-organs are there, of course, and each organ has to work. Only then body works systematically without pain. And because a person is healthy, means mind has to work, heart has to work, same with kidney, liver, and whatever is there, complete root is there, network is there, that has to work. If that network fails, we cannot live. And of course, everybody is related to each other, family-wise or otherwise. Every person has to think of others, and every person has to do what others want us. But what I have to do for someone, I do in time. That's what coordination is. If I say I have to work with someone, and I have to see that person, or without seeing, even if I have to contact that person, what purpose of that work? That person is to be contacted. Either I contact or that person, or both contact each other, and that's called coordination. Also, we can say the coordination has different means. Of course, it includes relations. It includes it includes connections. It includes relates, and of course, it includes timings. So we have to care about time, we have to care about time, and we have to care about others, and we have to care about questions, answers, and all that. So coordination is something that there's no difference. There exists no difference. You are superior or inferior, means it's a question of, it's an issue that has to move together, just like, whole system works together. And so you see, if you have a solar system, solar system is there, and it works all time, it doesn't stop. It tells us what's coordination. We can learn coordination from solar system. We can learn coordination from the universe. And we can learn a system exists around us that coordinates all time itself without even telling us what it's doing. And we don't even identify. We say learn from nature. What's that learning? That learning is that means nature works perfectly. And that's important point. Nature works perfectly, and we have to see that. That's why I say at least we can't understand nature, we can understand our projects. We can understand, we can communicate. We use a lot of communication these days. We spend time on my mobiles, we spend times on talks, we spend times of so much here. Even I've seen people busy, remain busy all the time, walking on road. They're so busy, they remain so busy. The mobiles are careful who's coming behind. Even during driving, people use communication, use mobiles. Though it's dangerous, it's very dangerous. Now, how to use it. In that case, I can say, means coordination or communication is a network of communication, but you talk about coordination. I don't know what they talk, but I don't think it's a fertile activity, though they do it, they don't understand. But when, communication is not very expensive, you have money to spend, but the question is, what's purpose? Purpose is whatever activity we do in life, in works or otherwise, should be pointed, should be focused, should be fertile, should not be wasted. My effort should not be wasted. And if I think that my effort should not go waste, my time should not go waste, my cost within limits, I have to coordinate with all these activities. I have to coordinate time with money, money with quality, quality with this and that. As we say in our controls, say scheduling, we call it scheduling, right? Scheduling, schedule of plans we do. Make a plan for this project. People call it time plan, time chart. I don't call it time chart. Schedule, actually, it is a schedule, includes time, cost, and quality. It should have everything. Time is important because time is fixed on projects. You cannot extend time. Time is fixed, and you have to think of that. What timing is, how to adjust that time. You cannot exceed that time. Of course, you can save time, but you cannot exceed that time. If you exceed that time, the implications come on. It becomes very expensive. So time is one factor. Then we say time is controlled, means of course if prices are not escalated, the cost is controlled. And when time and cost are controlled, people work accordingly, and we can say quality can also be controlled. These are three minimum factors, but there's a procurement issue, there are so many others we can list out. Quality issue, procurement issue, speed issue, work is right or not right, we can say controls issue. Likewise, you can say a kind of network created on that schedule. You can say it is like coordination itself. Activities coordinate with each other, you can say time-wise, not quality-wise, time-wise. When you say from this is you can say level 1 chart, level 1 plan, and we use this is start date of project and this end date of project, that's called level 1. Likewise, we give further details, and we say we have to analyze whole project and list out activities, and then we say these activities have different dates, all lie within that level 1. This date of start and this date of ending, we say generally, and that's called total project duration is called project duration, and their duration has been further many times forcated into many more, or there may be many more components of that, and we accordingly plan. We keep start time or mobilization time or end time, or you can say testing commissioning time or something else, demobilization time. We remove this period, some first and last, and then we say this is balance time. So that's also a kind of time coordination. So we have to understand time coordination, cost coordination, quality coordination. Coordinations apply everywhere. It doesn't mean that we have to say coordinate person to person. Time activities are related. We say this is critical activity, this is parallel activity, these activities are parallel, these are in sequences, and these activities have limitations. These are long lead items, these are short lead items. Likewise, we consider, we check, it's very important. So it tells us how to do it. Means time chart or time bound chart, or you can say schedule or schedule or bar chart or plan, or whatever we can call it, program of project works. It tells us what is coordination. If you understand that, it's not easy to make bar chart if you don't understand whole soul picture of that work to go on. You cannot simply say sit there, use a computer and think date, feed one date and end date, and I got a bar chart and that's my program. You cannot say that. You have to understand where will be problems. There are so many activities we don't have. We have not done in field. You don't have experience of that. And in just doing bar chart is not enough. We have to understand impacts of activities on project. There are so many activities you don't know about, and if you don't know about this, how this shall be performed, you will just drawing bar chart has got no meaning. That bar chart tells you have considered every aspect of the activity or objective into your plan. You have kept time reasonable, and you know what cost would come. You know your budget, and then is it practically possible to work like this or not possible. It depends on your experience on that work, and that's very important point. So coordination engineering has got many relations, since you have to activity related coordination, material procurement related coordination, quality related coordination, and whatever else you can say. There is no other way. Other people related coordination, internal coordination, external coordination. Likewise, we can say it's a complete group of engineering activities and non-engineering activities. It's related to public and related to ministries, and all of this. It depends on what type of project you have. So we have to be very considerate about this. We cannot just take it for granted. Means we have to think all the time. And that's why I've taken into title all these quality projects. First, you can say it itself speak about it. So I'm talking of complete string of requirements. It's complete string based on analytical studies, and we can say coordination. What I have been able to understood so far, I will able to understand so far, is coordination is an important work, though it's not physically seen, but it's worked upon. And communication is, of course, we know it may be writing or speaking, or it can be through videos, it can be through internet, it can be through whatever media we have. Communication is always been a part of work, part of life, and it's still continuous, and it has been there for long. Of course, in past it was in writing, or it was in verbal talking or interactions, but now it's done through mails or the internet or video webinar, whatever we can say. It's kind of constructive, but we shouldn't make it waste communication. Waste has no meaning. If you talk personal or family, that's different, but as far as work is concerned, communication is very important part. This should be waste. This should be clearly understandable. We cannot just gossip and chat and say it's so. No, we should get some result out of that, and that's what we say. Network important. Concrete should be concrete base. There should be concrete requirement, and we should not waste time, because every minute sometimes is important on projects, performance. If you don't value time, time will not value us. That's all, because once time goes out of your hands, you cannot retrieve that time. It's no possibility at all. Doesn't no possibility exist. You may retrieve your time. So I wasted so many hours on that, and you regret only, nothing else more than you can do. We as a civil field engineering is therefore very important, because civil means public and field means works, whatever you do, and engineering means technology, required technology application. And whoever understand all this, who use this, have to focus on that, where all benefits to be gained. That's called reliable engineers. This gets benefit of working, and then they deliver this benefit to people, to clients. And therefore we can say this engineering is full of coordination, engineering is full of technology, engineering is full of all theories, and engineering is full of practicals, and that's all engineering is. Engineering has no definition independently of others. Every engineering is a comprehensive world. Comprehensive means it contains every requirement, it contains every design, every procedure, every method. You can see we have to define it in different fashion. We cannot just limit it to industries or to process, manufacturing, construction. It applies to all parts of life, but we have to understand simple engineering or complicated engineering, for project engineering or different engineering. Likewise, it contains all elements, as we say. It contains contracts, it contains safety, health, environment, it contains designs, quality, construction methods, all that. It's fine. We have to understand coordination engineering, and coordination engineering is a very important part as far as engineering is concerned. Those who understand coordination engineering, they can do a lot better because they know it's scientific, it's practical, it's engineering wise, it's technology. Coordination itself is a technical word. When technical questions are risen, technical answers are found out. It's not simply talking to each other. You cannot call talking to each other coordination. It may be called, okay, you may consider to some point, okay, I can say, because I'm chatting with this, I just want to give information, other person seeks information, I want to seek information from other person based on experience of that person. That way you can say, okay, it's information exchange, or we can say it's to some extent may be called useful coordination, but the real coordination is different on projects. Due to occurring complexities, due to state of complexities, interdisciplinary complexities, informations are not available. This is how to make it available, or these are to extract or dug out, and that's very important. If you don't have information, time is required. Your activity stops or is defective. It's carried out as it is without having information. And it's there a very important point of view rather than that. Engineering, we call it coordination. Engineering is very important for every subject, for every discipline or sub-discipline. Coordination lists can be different, and that's why we have to understand that we have to deliver. What we have to deliver is quality engineering works. It's not engineering works itself. Means whatever works we deliver should be quality based. Quality is a part. You can say coordination is a part of quality. Working is a part of quality. Performance is a part of quality. Individual approach is a part of quality. How efficiency can be achieved is a part of quality. So it's called profession. We should understand the profession is something we have advancement is required, and that's the meaning of profession itself. Profession means advanced studies, and which can be done only through works or through experience or through research or whatever you say. But communication, suppose, is a must, and we have to realize this fact. And where there's no coordination, I don't think engineering can be done. So it's a missing coordination. Missing coordination means missing good engineering. It's a very important point. If we miss coordination, we will miss engineering. We may be calling engineers done, but good engineering is missed. In Hindi we generally call it यदि समन्वय नहीं तो स्वच्छ अभियंत्रण नहीं. We can say if there exists no coordination, no clean engineering exists, and clean engineering means quality engineering. संचार आवश्यक समन्वय अभियंत्रण हेतु, and it's very essential that there should be communication access, and the communication should work for purpose of engineering, and that's engineering coordination purpose. Communication support for reliable coordination is very important. You can see, for example, I am showing to you this slide. This is a plate fun, I call it, in school project. Now what happened to this? We have a point of concern here. Means, of course, it's project as usual, but I'm talking about long time back. It was done. Its construction was done in 1986, 87. So you can think when it was designed of. Think of that. If its construction was in 1986, 87, in the 87 or 88, in that time when there was no computers, there was no, no such advancement of anything, and every activity was done manually. Even calculations were done using ordinary calculators, and you could see in those days when it was nothing, no facilities, no mobiles, no computers, nothing. In public life in those days, everything was done on paper, and landlines, you can say landlines were available. And of course, you can say how much troubles you must have seen on these such projects in those days. You can imagine how is a world where there's no facility available, nothing is available. It's very difficult even to write and type and send. If I write paper today, I write using pencil or pen or whatever, I have to give it to typist, for example, and typist is sitting somewhere else. So I can't fax, I can't do it. I have to take the paper with me and go to typist. Typist should sign, write it, type it, and then somebody will check it. or somebody will edit it and then again type likewise, and then we send it either through courier. And those days courier was not very common. We have to send it either through somebody would come and collect it, or would be someone sent to send it or give it. So then it will take a couple of days even for that paper to reach that person who don't want to give, and then those people will take time, and likewise it took about maybe for 15 days for corrections on something. So you can say time was very important those days, communication very slow, and coordination completely manual. So you think of means it's RCC projects about 1.5 year project or 2 year project, having so much quantity of RCC that had to be done, from one column to other column, from foundations to foundations. The structure and how many times concrete was done, I don't have the record, but it was hundreds times, many hundred times concrete was done. And concrete, of course, using mobile pumps and transit trucks, or sometimes using cranes, depending on the requirements. So I'm just trying to project this just so that you know how much difficulty would have been faced in this. Though it's all very small project, not very big one. It's a school project. You can say big in a sense, not big in a sense, but that time it was considerable one, because in those days it was 14 million reals, and 14 million reals means not. You cannot say 14 million real is not small amount. Was not a small amount, keeping reached position of construction engineering in those days. Why I'm trying to say that there was no computers, there was no IT, there was no CCTV, surveillance or SCADA. It was only ordinary electrical and mechanical, plumbing, lift, etc., etc. Such type of coordination, or government coordination, private sector, and likewise you can say ordinary coordination. But it took time that time also. There were architectural, structural coordination, external works coordination. Likewise, a list of coordination could be drawn. Now this I'm talking about building RCC framework, and we talk of something else. If you say we go and see about other items, and that is, say, for example, this is one here. This is photo of a plant that is constructed. It was a lot difference between previous one. This is in 1986, and this was done in 2000. Let us start in 2000 or to 1999. About 14 years different. 14 years difference. In two projects, there is of course there was some change in previous one, some change in concrete quality itself, concrete design itself. That's major change. Otherwise, computers were of course introduced in this project. When I was there, I could use computers in that, though, because I learned computer a little late, because my first computer learning was in 1999, but you may say matured learning in 2000 actually. So you may say I started using computers in 2000, and it's went on till now 2022 running. So if you see, in 1986 I knew nothing about computers, because these were not available, and this gap of 15 years I started in this project as whatever, and some computers were available. So there was some development, you could say. Development moved from no computers to computer. In fact, it took for me to get it in 15 years. There's a little question here: where are we moving? We are moving that time. Now it's computers, like it's a mandatory. You can't even respire. You can't even walk without computer, because you are using mobiles, and mobile means it's a small computer, mini computer. So you are computer born people who were born in 90s or 80s or 2000 or post 2000. It's computer age, you may say, not calculator age or not log table age, but this age will not also stay. That point we have to understand. So in 15 years there is a lot of difference, you can say, in concrete technology and science technology or surfaces technology. That time I said mechanical, electrical, civil, plumbing, all that were coordination related subjects. And here even design of concrete was related. It was concrete mix was revised, and there was no OPC, full or dedicated OPC, or only OPC. In a school project, I said OPC was used, SRC were used. There was a difference here. OPC and that's the OPC. You know what is OPC? Ordinary Portland cement I'm talking. When I say SRC, sulfate resistant cement I'm talking in that case. But when I say about this project, there was no SRC or OPC, and also in other projects I can say same thing happened. We have to understand that. Now what I'm saying about difference of 15 years, OPC changed to PFA, that is pulverized fuel ash. OPC was not accepted everywhere because OPC is basically basic cement actually. If you say original cement is ordinary Portland cement, and which gains high temperature, you can say at an earliest. It's temperature defect, you can say there's a temperature defect in this type of concrete. It can generally result into cracks formation if not properly handled. And ordinary Portland cement means ordinary use, not specific use. It could not resist sulfates, it could not resist many chemicals available in soil or elsewhere. But there was another one, that is sulfate resistant cement, SARS we used to call it, which was used generally where soil contacts were available, soil contains chlorides, soil contains sulfates, and likewise you can say. And many other, the main was sulfate resistant cement, and that was used in foundations particularly. And these were to have different compositions that we could not mix to also. I'm just giving references, but now if you consider on this plan, on this project, there's a big difference here, 15 years difference, and OPC was not directly used absolutely in pure form. It was replaced, part of this was replaced, 25 to 50% or 75% were replaced. Sometimes 70% was replaced. We have then, you can say development told us that you have to use PFA, you have to use GGBS, or you have to use MS or microsilica or many others. These are three main, microsilica or you can say silica fumes. So we can say concrete change is structural design, I mean to say concrete design, concrete composition, different composition but with better quality, of course quality in different sense of performance. And we can say in that case here there's a different understanding. We could say it was not ordinary Portland cement but modified Portland cement, you can say ultra Portland cement, which could add to protection from cracks, which could generate lesser temperature than OPC did. It was something like, of course this was delayed final setting or delayed final strength achieving, but for purpose of other technical or defects rectification, it's a better one. So there was a difference, 15 years can say in this case, and it's only have anything that's but later in between this. If I go to 1986, not exactly 86, 1996, 95, 96. You'll see 96 what happened. 96, of course, GGBS was not that famous. You can say popular. SRC was popular, of course, in that days, but in fact, SRC was also not popular. You see, MS microsilica. I completely studied that on one project. I was working on LNG plant and one project at Beach Villa in Qatar. I was working on that, and of course was working on this LNG, you know, LNG. If I say there's LNG here, you can see that LNG. Yeah, I can show you what it was. Yeah, I'm just trying to reflect how everything. I don't know, it's here. Yes, it's in row. If you can see many projects here. Problem is, if I stick to that browsing and say here plate 8, and that may be not this one, school this is, sorry, hospital this is, yeah, this LNG. If you can see this LNG here, this was, I was involved actually on these. You can see these tanks here, 3 tanks and a 4th tank, and this was where I was involved as a project officer engineer. This for purpose of recording so much and checking so much, but also I was talking control of another villa I'm referring to this. This is also same. Here also concrete of a GGBS type, you can say PFA type was used. Villa photograph I don't have, but in that I had to coordinate completely as a leader of technical leader of that project. I had to coordinate accordingly, and I had to say means why I'm trying to tell you this. There's a reason for that. It's very important item that we can say. As far as silica film is are concerned, because you can say, as far as silica film is concerned, I on that project I coordinated completely. I did not have knowledge of computer, of course, in that time. Computers were available. I did not take any interest in that. Many people forced me. Many leaders forced me. Many engineering leaders forced me to use computer. But I was scared. My eyes would be badly affected, and actually it was a fact. Now my eyes are affected. No problem. Life is moving by. I say, I'm trying to tell you about that project. Villa is it was Hoodie's lab villa, Hoodie Houdi, Hoodie's Arabic word. Villa, that is free, is a kind of flat surface design. So design is same, structural design, the flat surface design, or you can say, in that case, all they used is microsilica. I learned there what microsilica was. I studied that literature of microsilica there itself, and there was beautiful technology involved. In fact, you can say silica fume. When we consider silica fume, I'm just trying to tell what it is and how does it work. When silica fume says very small particles, these are smoke particles, you can say fume particles, smaller than size of cement particle, much smaller than size of even smoke. When you have smoke, this is particle in suspension in air, very light particles, and these can fly in air, remain in suspension for hours together. And you can say silica fume is that smaller size, or you can say of same size of particles of smoke. And you think of these particles of smoke, and cement particles are even heavier than that smoke. Well, how does it act? That's the point. How silica fume, what we name is trade name is microsilica. How does microsilica work into concrete? That is very simple, very elegant. The answer is that it coats particles of cement. Silica fume performance says that it coats particles of each particle of cement. You can say cement means a specific surface of cement is actually protected directly, you can say, even if cement is mixed with ingredients, stone aggregate, sand, or you can say water, even after mixing. And if silica of whatever percentage is mixed, microsilica, even up to 9%, 4%, 5%, 2%, 3%, whatever it is signed in, that portion of microsilica remains intact within concrete, and even after mixing, it remains in suspension on particles of cement, and until it is acted upon by thorough application of vibrators or compaction or coordination. We call it compaction or consolidation. Some call it compaction, some call it consolidation. English uses compaction while American call it consolidation. That doesn't matter, but question is until we break silica bonds, microsilica bond with aggregates of cement particles, until we break that bond, reaction of cement and water doesn't start. Here I should say cementitious materials or supplementary cementitious materials, that is microsilica you can say. And it may take, if you don't apply vibrator, even after pouring concrete shall not set immediately because of coating of cement particles by microsilica, which acts as debonding or suspension agents. So that's beauty of that. So it takes time. You have to understand this basic requirement. Therefore, microsilica is a kind of reliable material for this purpose. And when microsilica is used, because silica fumes, it is same as sulfate resisting cement. And also there are so many issues that we can control cracks formation, or we can say it's also a technology used for prevention of cracks. But it's very expensive material, of course, and it is not used more than 9 to 10% maximum. It's not like GGBS. Why GGBS? I'm talking, there's another issue here. So what I say, I'm just trying to tell how does concrete change, how did it change in history. So I said I used microsilica in 1996 or 95, and that's one part. And if you go further onto that, when I was just in 1986 school time, there was only OPC, and here there's a change of microsilica. And if further go on to this, you can say, if you go on in this project, I'm talking about this ethylene plant. This is 2001, 2002, 2003. There was no microsilica there, but better than microsilica, you can say. Microsilica, because microsilica are expensive and there's a limitation of that. Then we can see we have all finally PFA. PFA we call it pulverized fuel S, and also one is GBS we call it. Now it's very common. Glass, granulated glass, say blast furnace slag, which is in abbreviation form, which is called GBS. PFA, these two materials are also very important for us to understand in coordination, because you have to coordinate, and these techniques are considered certainly for that purpose. So if you say PFA and BBF, these are also related to replacement of SRC, and because this already fly ash PFA, and that is also a kind of slag that helps concrete. When you use PFA, if you use, it's also called supplementary cementing material, as well as GGBS is also called supplementary cementing material, and these are to be used in combination as well as independently. Generally, you can say these days cements have a use of inclusion of PFA, but that's the maximum limitation here, because PFA depends on specific area. That's not unlimited, but GGBS and FA have some difference, because reason being that we cannot control PFA more than some limit, but GGFA can be controlled in a better way, because of grinding properties of this fineness can be increased. But in a PFA, there is a limit more than which you cannot do, and we have to therefore use combinations of either, or we can say, to my experience, I use GGBS even up to replacement of 70% of OPC. Means if you use whatever quantity of cement in designs, 70%, the ratio proportion 70% GGBS could be used, while only 30% OPC, and PFA it is 75% OPC and 25% PFA. Whereas in microsilica is a percentage of cement that could be up to 9%. Generally use 2 or 3% for purpose of only control, and for better control up to 9%, so that you can control your corrosion and control from many other viewpoints penetration of chlorides. Same way it happens in GGBS also. Varying properties are there, but we can use GGBS. GGBS is very common these days. I don't know why our people in this country are not clear about that. GGBS is very important material, I have to understand, and nowadays GGBS is in common use everywhere, and controls are better in case of replaced by supplementary cementing material contents of OPC, and therefore it's a great technology. And moreover, it's not only replacement of crack control or temperature control, and the point is also, you can say, carbon dioxide control. 1 ton, you can say, in 1 ton cement, approximately 95 to 98% released as carbon dioxide. Means equivalent kilogram of carbon dioxide is released when we use Portland cement. This means it's a question mark. Would it not add to pollution? Yes, it will purify air, and it is a kind of greenhouse gas, and this impacts upon conduct properties of air. And heat is generated in air, of course, but when we use GGBS, 85% reduction happens in carbon dioxide content. Release is 80%, 85% lesser. So you can say if you want to help air be little lesser putrefact, or you can say polluted or putrefied, you can use GGBS. Of course, not 100%, but 85% reduction is quite considerable. So we have to use it intellectually. I mean to say, we have to understand materials technology. It's not simply, if you don't understand materials, you can't do anything. And of course, crack controls, so hair cracks, other cracks, and slump control, and also you can say ease of pumpability, ease of construction, ease of building. So many other points are related which you have to know. So I just tried to explain on this project we did about, I had a problem here. In fact, I I was working on a compressor foundation, big foundation, about 500 cubic meter concrete in one go in massive block of foundation. You think of massive block when we say complete one foundation, and say it is having 500 cubic meter of concrete. You think it's easy. Depth of that foundation may be around 1.8 meters, width maybe 12 meters, and length may be more than 25 meters. And let us, I'm just giving indicative dimension, and maybe 400 to 500 cubic meter contents of concrete in that. You have to, in a depth of about 2 meters, you have to pour. How do you pour? Can you imagine? Can you think of? Can you chart out procedure? And I did that actually, based on my common sense and specifications, and never mandate that you have to pour so many meters depth in one go. You can't do that. Concrete does not permit that. So everybody knows that in concrete we have to pour in layers, and layers should not be that wide that when you come back from one corner, other go and come back, maybe your concrete starts setting in. So you can't pour on that directly other layer because of formation of cold joints, and cold joints are not allowed. Cold joints means one or old concrete has become cold and next concrete comes a hot. There is no same temperature approximately. So this is cold joints. One is already setting, others has to start its reaction. There's a difference of temperature between two. That's a point of concern. We say it's not hot now, it's starting working out. And at that point we had to protect, we had to understand this point, because in layers cold joints are not permitted. That point. So how to solve that issue? Specifics required, no cold joints, and we should say then we have to pour some concrete in first go and second go. We have to make sure that there's a time gap. We should not exceed to do concrete on both or whatever exposed surfaces or uncovered surfaces of that layer. You have to pour before that time gap, whatever gap it may be. So I had to chart out a procedure, and I did that. In this, you can say I did not exceed 2 meters layer in width and 40 centimeter or 0.4 meter in depth. That was practical layer, you can say, not final layer. And then we have to move in a sequence that we have not to cover whole area in one go, in one layer, but only small portion of say 2 meter width, and then we have to go to other one and then come back to first one on top of that, on top of first one, then to another layer. Likewise, we have to go in a step sequence. It's called stepping. You have to move in a stepping sequence, and also stabilized sequence, because you have to apply vibrator as well. So that's a very important point. We have to cover sequence, and I meet that project procedure for this. And of course, because it is a massive block, and layer is down and down and down, upper layers are near to air, while down layers are away from air. Therefore, there are chances of generation of heat as well, even though use GGBS heat would generate. How much heat is generated, not generated, that's also an issue, because a lot heat means a lot chances of it cracking. So temperature controls are must. And so when, okay, a question was raised, how shall you cure this concrete, this massive block concrete? I thought water flooding will do, but no, I was wrong. Water flooding won't do it, because it's voluminous concrete, the volume of concrete. How to do that? So my method was objected at this point of curing, and that person was expert of that time in concrete. He raised question, consultant on behalf of company. I don't want this type of curing. You have to tell us how to do it. And say you have to do thermal curing on this concrete. And what do you mean by thermal concrete, thermal curing? And he simply said that why is concrete cure purpose is evaporation happens, and we have to avoid that. We have to replenish loss of water due to evaporation in concrete. We have to replenish that loss, and then we guess that means you don't allow evaporation of concrete and use that for purpose of curing. Well, I got his point. So okay, I got your point. Means purpose of curing is to protect, to help concrete regain, rehab its water lost due to evaporation, replenish that loss, and that's basic purpose. So the water is not evaporated, so concrete remains dry. That's not possible to work. I got it. So don't use water, but you don't allow evaporation of concrete. And tell me what's the way. This I mean, he just also suggested that cover concrete with something, and polystyrene or some board somewhere, so the heat remains inside. And then you keep it for 72 hours at least as such, and no need of water on that, except temperature outside should be controlled. So I got his point, and I said, okay, we'll use your way. We won't allow exposed surfaces, unformed surfaces to release heat, and we use method for that, and kept it wet for 3 days outside temperature. Also, so the temperature remains in control. And that was another learning on this project. You can say it's a kind of complete technical understanding of what we have to do. So these are 2 points. So I just tried to explain to you how that world behaved in those days. Now this was different concrete, but also temperature controls have to be charted. How to control those temperatures? We have to use differential thermometers on that concrete. So no internal temperature and external temperature. Internal temperature of concrete mass as well as external temperature of air. There should be little difference, marked difference. You'll see that in concrete specifications. I have a copy of Qatar 5. We studied that. I will come back to that one. I'm just trying to say how we used to coordinate technical requirements of the use of that one. And that's really something very important we have to understand from each and every point of view. We can't go without that. We can't say no what yes, but we have to understand that. I'll put off my computer just a minute, because it's, let me see, and we can say, hold on please, and I have to see that one. Let me cover this. So we have to consider this way now. If we go to another one here, if this is of course 87, this was. Now, this is a ordinary project, you may say, very ordinary project. Uh, but here, it's electrical, mechanical importance here. Here is civil importance here. How to do work in civil engineering. I will just tell a story of this project. It's actually very small, but it's like professional work on this was carried out. You can see yourself, plywood was used for formwork, but what the story behind this is very important. I was very serious about foundations. Very serious about foundations in this project, and in that area where this project is located, soil is not to that mark. Soil is not to that mark. This means soil is clay, you know, it's clay that is probably it's having Montmorillonite content in that is soil minerals, clay minerals we call it, Montmorillonite clay chemicals, minerals, and that's very harmful. Engineering viewer says the Montmorillonite or Calonite or Illonite. There are many names, but Montmorillonite is very dangerous because this mineral comes in contact with water. It swells many times, hundreds times, or percentage wise it swells, and when moisture is evaporated, swelling many times and also shrinkage cracks. Both are very dangerous for founding clay, founding buildings on clay. But people do not have that thinking. In fact, it is reverse. Some people think because sometimes when clay is dry, it becomes little stiffer, and people think, oh, it's stronger, it can give good bearing capacity. But they don't understand clay is not linked to bearing capacity. Sand or granular materials can be linked to evolution of bearing capacity or attainment of bearing capacity in that material. Clay is not related to bearing capacity but to shear strength. Cohesion based shear strength, because particles are very small size. These clay particles, 0.0002 mm, you can say normal, and these are not adhesive to each other, you can say. Water can't flow, but water remains in absorbed form. Water remains in contents, not moves from one part to other part as it does in sand or it does in granular mix. Water can flow through it, seepage otherwise, but in clays that remains in suspension, and that is very important point to keep in mind. So we have to understand, we have to differentiate between clay and you can say between porous material and permeable materials. You can see there are two kinds in soil. In soil, one is porous soil and one is permeable soil or permeable mass of strata. You can say when it is porous means water remains in suspension form within that in contents form without any mobility, but it can evaporate only. While in coarse or in you can say in graded form or cohesive matrix, it is different matrix of different size particles. There's just an absolute chance of movement. Water can penetrate through that, and it's called permeability. So porous soil has no permeability, while non-porous soil or granular mix has permeability. That's called permeability coefficient. But the question is that why? Because clay is porous, it doesn't allow water to move through this. But another particle, and the property of clay is that it allows capillary action. And capillary action is also very important. What's capillary means it can form vertical columns because of porosity. It can gradually, very slowly move vertically upward, and it can reach foundation points. It can evaporate as well, and that can, if it evaporates, the volume of clay can shrunk, and there's a chances of settlement. And also when water level rises or water contents rise, it can force that layer to move upwards, which can call upheaval. So in case of upheaval, it can impact adversely your building. At that point, we have to take into consideration, in both cases it's dangerous. But when we talk of granular mix, that doesn't have any settlement immediately, even after compaction, consolidation is not a big issue. But in clay soil, consolidation is very big issue. It may take many years for consolidation to happen, and that's really a very important point. We have to understand how can consolidation work, and that's why I'm trying to tell you what I did in this case. First of all, in this soil study was conducted without tests but observations only, and reached a decision because clay contents had to go down, say 5 meter below surface of ground for purpose of basement. I said no, we have to change the soil a little. We have to make changes in soil. We have to understand that point. We have to improve that soil, and that's very important part of this. We have to improve soil, and how to do that? There's a question mark here. So I decided to replace to replace I decided to replace 300 mm thickness below formation level. Formation level means foundation level. I decided to change soil of that strata because I didn't want to take any risk as far as clay is concerned. Its structure, it's not road work, it's building, and of course it is located in zone 4 according to ice codes, and zone 4 is of course dangerous. Zone 5 is more dangerous, and zone 2, 3, I don't think that's much problematic. So in zone 4 this building is situated, and I said no problem, I will not allow any water to be stagnant around foundations, but must have good permeability around. I won't allow any soil contact with foundation vertically as well as horizontally, because people don't understand this. Contact of clay with foundation causes many problems. Problem number one is water soil mobility, water mobility both. Water soil mobility in pure form, and water soil mobility or soil water mobility you can say, and then also Also, it is agricultural soil. Clay is used in agriculture. And then there is the issue of bacteria growth, there is the issue of organism material growth, or you can say aniseed, or white ants, you can say white ants. And this can decay. These germs or these bacteria or these insects can decay your soil. And of course, rats do a problem. Well, that's distant away from this. So why not to isolate clay from building directly, so that its impact should not go to structure. And that was my point of concentration. So I said, okay, I will improve this soil to some extent. I could do more also, but I said, this is not such type of structure. I just want to keep waterproof foundation, not to come in contact with soil, so that no chemicals or no sulfate should come touch your foundation. Airless water doesn't stagnate around, it keeps on laminarly modified. Laminarly in mobility. Laminar means not turbulent flow. Laminar means in layers. It should move gradually. It should move around. My building structure should remain off water, and that I did. I provided granular thickness, granular course of 300 mm. And when I say granular, it means stone granules, not soil directly. There's 40 mm aggregate we used for direct placement on that, and whatever voids were available, that were filled by another aggregate of 12 mm size. And then you can say whatever remained after that, whatever voids remained after that, we filled with dust. So there were three combinations: a stone aggregate 40 mm nominal size, and then 12 mm, or you may say 12 mm nominal size. Generally we call 10 mm, this 12 mm which is. And also we said that we'll use then dust, which is stone dust, and packed water bound, not cement bound. Packed water bound, so that these remain chemical free. Water bound is water is evaporated later on, and we don't use cement, which means this is alert material, inert. No cement means no chemical reaction. So this remains inert material, inert strata it is. And on that we did blinding work. Blinding means concrete for foundations. This was treatment applied in foundations for purpose of, and of course we did waterproofing for whatever you can say, that's different issue later on. And also in vertical positions, we didn't do any brickwork in foundations, because I was not having any acceptance. I don't accept brickwork we done foundations, because bricks here are not well marked. It's not even machine bricked. Ordinary bricks having lime contents, clay contents, and listen, you cannot say these are structural usable bricks. We didn't use single brick in foundation, only RCC in walls, RCC in columns, RCC of course in floor. And I didn't want in these vertical positions, vertical surfaces of RCC, or even horizontal surfaces of foundations, to be in contact with soil. So vertically also I backfilled with about 40 centimeter, I don't exactly know width, with river sand. River sand, we call it fine sand. Raita, we call it trummel. I fill around, and then we say soil. So vertical portion should also be permeable. You can say vertical. Of course, we did that successfully, and whatever we can say, as much as possible in private buildings, you could provide resistance to that. And you don't use any pesticide, because it was in that case not necessary in absence of clay. So that's what I'm trying. Another point we did for reinforcement and for formwork, we used only plywood for formwork of RCC. Everywhere in foundations in columns, in beams, in slabs, only RCC plywood surface, because I didn't want to do plaster, just leave as it is, but just as an experiment. And wherever ply was used, no plastering was done. There was one point. Other one is that reinforcement. First of all, I did not accept any rusting reinforcement. That's the main point. Why should I allow rusting? I said no rusting is allowed, no bent parts are allowed. Generally, what happens in our country, standard length of reinforcing parts always 12 meters more. And due to many reasons, people don't want to buy straight bars because of transportation or because of keeping them at site. When the site's open, there's no problem, they should not go long bars. Okay, in states we may say that trailer cannot enter, but here trailer can enter, so what to do? We said no, we'll buy straight bars. Top, we paid extra for trailers, no issue. But I stored them. I went to one, steel fixer, contractor. He asked me, this is my work, you have to do it. He agreed. But I put these conditions that we will get straight bars and you have to protect these bars from atmosphere, from air. And you have to protect them on site as well after installation, fabrication, erection, or you can say placement. That person could not understand how it's possible. You have to protect them. Use plastic sheet on that. That person started laughing. This is not done. You're first person to talk about this. Then you have to do it. If you can't do it, okay. Well, he did not agree with that. I told I will provide plastic sheet to you. You have to do it at site as well as. He did not agree with that. Okay, thank you very much. I told him I don't need services. I hired someone else and asked me, you have to work on this site itself. You arrange, if you want extra payment, I will give you. And of course, I had no other plan except to use 12 mm dia bars and 8 mm dia bars in this small quantity, 16 mm also small, very small quantity. So we agreed with that. I'll pay whatever rate you say. It should be justified, and I said, okay, no problem. You will work my supervision. I'll give you bar bending chart, bar bending schedule, and you do accordingly. Only 12 mm, when you sell steel diameter is small, say 12 mm or 8 mm, it takes a lot of time for 1 ton quantity. So what they of course think is more diameter means less time, and less diameter means more time. This is natural, so no problem, that's work. And of course these people started work, and I did not allow any rusting on that. We covered with plastic sheets when in the store, and we kept off ground using some timber or bricks. No touch of soil and no exposure to moisture from relative humidity. And when they took out bars, they covered back, same on roof, on slab, on columns. We have to protect it for impact of corrosion. And throughout this project, there have been some corrosion, some rusting. You have to brush it out. I specifically brush it out. Don't use without that. That is one point. And other one that I used only 8 mm bars in slab reinforcement. Not ordinary design is compressible. Its compression steel based design means steel in both top and bottom. Top mesh and bottom mesh, you can select that. Not we live in hogging also, in top also I use this so that it becomes a compression member, and it should have compression reinforcement basic requirements also, that it impacts good on deflection. You can say deflection chances are reduced. So I did double reinforcement slab, upper layer and lower layer, as well as everywhere else, so that steel could also be utilized for purpose of strength. These were many points that we did there, and of course I did not plaster that except your bricks were used and nothing else. And of course, it's very difficult for them. Well, no issue. I just tried to explain to you what you did. Then here in roofing also is a different changes. I did not use inverted system. Our system is followed here. System is followed here is just mud filling. You can say they fill mud in roofing. I didn't accept that because ultimately mud is also clay based and no clay is allowed. So I didn't do any mud filling. Rather, I put whatever balance we had, timber scantling as well as plywood. Use plywood. I put a platform on roof itself, a small depth platform slope, and there was 1.5% or 1.25% to 1.5% slope on entire slope. It's like slope towards disposable towards rainwater outlets. And this, first we made timber backing and slope, and then of course, and before that timber backing we made levels and radial profile. Timber backing on this plywood was used. I didn't waterproof that because I saw the slope is enough and plywood itself is waterproof ply. Of course, it's damaged due to use, not exactly new at that time. 5 or 6 uses or 4 uses were taken. So what happened then is said, okay, then I put that platform like a timber platform that or which applied little tape crate or not perfect, and you put concrete on that concrete layer, and on concrete provide stone flooring, and I of course applied some bituminous application onto that timber. Uh, of course, some settled later on, which I do not care about. Of course, it's slab. I could not control joints. I did not feel any silicone in that, and these joints are a problem. Water could penetrate down. I'm just trying to say how different it was and what we did. This was only that. Now I points about some element that. Uh, then is another point that we use this. If you see this here, if this this portion, it's continuous beam foundation, or you may say framed foundation, or you may say kind of horizontal boxes connection. I mean to say, you can see this complete. If you see plan of this, all beams are connected. You can see this beams is all continuous beams through columns. Yes, through columns. Continuity of columns. Beams through columns as kind of horizontal frame, not vertical frame. Horizontal beam frame, and this reduces bending moment in foundations. Cantilever bending moment doesn't mean anything here. It's only fixed beam continuation, and you can say framed. It acts like a portal frame for vertical forces as well as horizontal seismic actions. When columns are there, when during you can say during earthquake action, these beams work as column, and you also can say these columns work as beam in that case. So you may say that impact of force, seismic force on on this frame. You can see this frame means this whole is framed continuously. This is the horizontal force coming onto this. This frame is very resistant, heavily resistant to that force. If you consider horizontal force coming onto this section, what will happen is a very strong column. Its size is 40 centimeter by 120 centimeter. It's very strong column, and this will give better resistance to that force, horizontal shear. And if it's both directions, what will happen? Even if building dances, it will stop dancing after some time. And that's main functionality here. Dance will stop. Even if dance is longer, Let's see where we consider acceleration. It will be digested, it will be, you know, adjusted. And these are certain features I tried to explain to you about this building. And really, when we consider in designs, we consider that point of coordination, and that's why stress on coordination engineering. Now, why say in buildings coordination is like that, architectural and structural we have to understand, and we can say structural and services we have to understand, and we can say we have to understand mechanical or air conditioning services to electrical services, all these services to plumbing connections or plumbing locations, structural and all these services, architectural and all these services. And we have to understand decorative coordination. We have to also understand building management coordination, which is also a very important subject. Just like these days we say 3D or 3D coordination through BIM, but that's not very important here. I'm not interested in talking about that. Now, what I'm saying is, in buildings in those days, talking was architectural structural coordination, structural architectural coordination, structural services coordinations, or you can say first fix coordinations, HVAC, electrical, electromechanical we call it, architectural, structural, and lift coordination, lift well coordination, or you may say many other type of coordinations. Building management is very important one. And of course these days we have security officers, surveillance, and many other, we have server floor, we have this floor, that floor, all that. That's all we have to think and understand. The list of coordination axes that we have to do it these days is every day increasing, because complexities of services we have to provide buildings. And of course gas services, there isn't that much coordination, but whatever is services there. And we have to, and in plants also, and plants, as I said, is for buildings, we have to consider about methods to how to concrete the higher levels. It's when you have many store, that is 15-story building, you are costing 20-story building, how to reach your concrete to that place, that location every time. You have to vary design mixes, you have to, it should be suitable for that travel, and we take it through staircases, otherwise we cannot take directly vertical stack of pump. So we take it on the stairs, waist, and then on the other floor like this. Or we may have to change some station between transit station also. That depends. Transit station, and that depends on how to design it, how to experiment it. Very important point, and we should have all these points are technical coordination, technical requirement to put in. Doesn't matter, it should be interactive, but it can be independent as well. So we have to, that's why I say coordination engineering is something very general, very specific, or very much unexpected. Sometimes we don't even imagine what we have to do. We have to do depending on site requirements, depending on works. And if you can think that in advance, we can assess in advance, it should be advanced problem can be solved. And that depends on experience, how much can go into depth of that subject, how much study. And it takes time for studying, specification still takes time, because there are hundreds and hundreds of specifications everywhere. It takes time to understand technology and then to apply it. You cannot apply blindly, we have to understand the methods of application. And that's given somewhere in catalog and in literature. That points really very, very effective, very effective understanding. So we can't just take for granted what you say, but to understand that. That's why I say coordination engineering is something we have to relate to designs, construction, and controls. And we say designs means, for example, I give you need microsilica or GGBS. We have to consider that point in design. In design, you have to consider this, that. Of course, ultimate strength of concrete is same, but in between there's a variation on formwork, striking. That's main point here. Formwork striking can take time because of early, late setting. We can't compare two settings of concrete. Same PC sets earlier. It sets early, but 7 days same strength cannot be achieved on GGBS. A little lesser, but this means you have to allow more de-shutting time to keep shutters there until it's ready for striking or for striking. And this also impacts on scarce planning, as it impacts on designs. It impacts on planning as well. And planning means it takes more time, so that time is to come to picture. This is maybe you have to do more quantity of work at one go, and that's why I say design, construction, controls are all linked together. You have to give value to that one. So you can list out, and now the important point was building management and gases issues. Now I'm not talking of just one area, other area. Now you can say building management. There are so many services in buildings. All services are very critical and very important. You can't avoid them. But why safety is involved? When I say safety is involved means it is fire, safety against fire, safety against something else. It has to keep involved means we cannot keep everything automated, but in building management it's made that you have to additional alarm when some critical point reaches, critical temperature reaches, particularly in HVAC work, it's air conditioning work, and fire alarms are related to each other. HVAC is a heavy, heat, ventilation, air conditioning, and that is very important point because there can be volume controls problems, there can be heat problems, there can be airflow problems, there can be condensation problem, or there can be whatever else. System is called installed one, first class installed, but performance is also important. Performance of HVAC is important because many results, many ducting system have resulted in fire. Due to whatever reasons, fire damper did not work to that extent as it is expected to do or intended to do. And that's the point we have to consider. Heat, ventilation, and electrical coordination are important because electrical means smoke detectors. It must be there, and this must relate to each other. So some competent person, we should understand how this is. So that's one point here we have to deal with. And also there's another point of fire extinguishing, fire fighting, and fire prevention. Both are there. Fire fighting means in buildings, if it happens, and particularly in hazardous area, it has cause accidents, and that's the point we have to see. We have to understand how this area happens, how gas production area, gas fire production, there's FM system, FM 200 system, and there's the inertial system. And inertial system is very important because of cylinders there. And inertial says that you have to take care of me, I'll take care of you. If you don't take care of me, I can't take care of yourself. That's a strong point. Means within seconds, if you want inertial system to work, that system must be nowhere. So we have to keep this point here, that is about coordination engineering. We cannot just move on and on without any relevance, and we have to understand that point very clearly. We have to be very careful about this. We cannot take it just for granted, but for just application purpose, and we have to view this point accordingly. And that's why it's important. And let me see, temperature is 10 degrees, and that's why I'm feeling it's 13 degrees to 10 degrees now. Oh my God. And that's why I'm feeling uneasy, no problem. 10 degrees at this moment, and it is now 66% humidity and slightly dry indoor. Day temperature is 27 degrees expected, and next day is 12 is shown, so it will be lesser than that. So now it's 10 degrees Celsius, a critical one for me in this month of February. So yeah, that's why I try to see this. If you want to show, I can show you also this, no problem. We'll just recommend, and you'll see this. Why I'm saying it's important one to keep watch and everything, and that's also important one. Right, the loading is coming in, and it says that you can see this temperature here now, and this you can see I'm printing it out, and you can see stand degrees here in PDF format. It's coming, and it's now in here. You can see this format is coming, and of course we have to be realistic in this to keep watch, and it's coming. Hold on. Come on, don't waste time. We have time for this. Not responding. What's not responding? It's come. It's responding now. So it's there. You can see here. It is 10 degrees. It's current weather February 28th, 5:16 a.m. It's partly cloudy, 10 degrees. Wind is 14 km per hour. Wind gust is 22 km per hour. Humidity is 66%. Indoor humidity is slightly dry, 34%. Dew point is 4 degrees. So 10 degrees and 4 degrees. And pressure is ordinary and 31% cloud. Visibility 16 kilometers. In daytime is 27 degrees forecast. And forecast is this, and maximum UV index 6 high. Expected is 30 kilometers wind gust. And next day is 12, so it will come down to, of course, something. So I wanted to show to you all this and keep it off now. So we can move on to our subject. Just try to show you how we have to link all this, and now you can say, okay, that's fine. Come back to coordination engineering. Coordination, as I say, is a very important point in the engineering world, and we have to be a little serious about this. It's not only that. We have to be serious. Everybody of us should be serious because it is coordination that helps us, and it helps in quality and coordination also. Quality is important, but you have to, every day I talk of quality, and quality remains with me in my mind. I see not serious means these days people are not serious about quality. I think quality culture has changed. That if no quality means no problem, people think so. Is it? No, I don't think so. But this is general. People don't want to learn any quality. They don't want to learn how to get serious about work. They just want to remain in their mind without any narcotism. They want to enjoy life. You keep enjoying life, means not face struggles in life, and quality is a struggle. And quality is, in fact, very poor. Can say no value of quality, if no value of coordination, all this. That's why we have to keep sleeping, or we have to get awakened, that we have to decide. No one can help it, and for coordination engineering is so much different. We can say it's for everything. Coordination engineering is a must on every project. Let us say if we can do something on this. Coordination engineering is a must. Is it a must-able or not? That's the point you have to consider. Are we so serious about this or not? That's the point you have to consider. How can we help? It's the point we consider. So it's a very serious issue, coordination engineering, and we have to coordinate. We have so many ways to coordinate, not to for coordination, but first we have to understand what we are going to do, and that's an important point. What we have to do, we can't say otherwise. What we have to do, we should do. That's right. For example, there are so many activities in buildings. How many of you understand? I'll let you know means what we talk about this and how should the points very very clear. We can find out anything in that, but I speak something from my own writing. As I showed to you this book, which I showed for cover here. I can so we can talk something out of that. Is that? But we can't do that. We can take something out of that in this book. I would say it's not actually, it's just a note, so many notes are here in that, and we can take those into consideration, and some activity list is there. It's very dark actually, I can't speak. It's very very dark. I'll take it some other time. But what I say based on my more understanding, how do we say what activities we have to think of, what activities we have to consider in buildings, let's say, or in foundation, let's say. In buildings, what we say, first of all, we have a list of activities which everybody knows, and give you this on writing also, but Here I'm giving just for every bit talking of the concept of this. Every consider this. Write something on this. Whatever comes to my mind, we do it. Depending on, I want to bring my experience on papers, or could learn papers, and that's very. For example, sometimes constructability is, I can say constructability as a point which is standards. Just by chance I got here. I can say constructability is a dominant issue. Constructability is a dominant issue in current advanced technology applications scenario, which of course lacks in training at first level of education. It should be kept in mind that engineering is a factual world, and no fiction can be successful, which means that just talking is not adequate. A work delivery implementation is necessary. We have to understand this point. Constructability means no way out. If you don't do, always says before that, total concept of constructability, buildability must be taken care of during all such designs, and respective coordination, which if ignored could mar smooth execution, possibility of project work activities, resulting in certain delays on completion time. Why we say also that design within this stage must be coordinated. What stage that's different? Designs within this stage must be coordinated correctly to an extent possible among various disciplines, say between architecture and structural disciplines, structure and services disciplines, and all other disciplines, whatever being involved. And before that also, so many activities are given that right now. I'm talking of constructability, which is very important one, and we can just understand also in our part of such, though everybody knows this is there, but what we say constructability means actually. Constructability, let us say, constructability meaning, let's say constructability. It is constructability according to Wikipedia, which says constructability is a project management technique to review construction processes from start to finish during pre-construction phase. It is to identify, you can say, it is to identify obstacles before a project is actually built. Let us say constructability, Wikipedia, what it says. Let me just see and tell you. If it's a long one, it's not long one, so I like just okay. Let us say constructability. Let us say constructability. Hold on, please. Just a minute. Let me see. Let's show you also that it's better. It's ordinary one, so you can see not a big issue. Just for information, I'm trying to find it out for your purpose, so you can understand better. Nothing secret here. Also, what's constructability? Let's say Wikipedia says constructability or buildability is a project organization technique to review construction processes from start to finish during pre-construction phase. Is to identify obstacles before a project is actually built, to reduce or prevent errors, delays, and cost overruns. Now, it defines let's say, defines constructability as optimal use of construction. Optimal means the best one, you can say, whichever is best out of the nice and expensive, not should be so cheap, but it should work also. And that's called optimal, a kind of ideal condition, we can say. Optimal use of construction knowledge, and experience in planning, design, procurement, and field operations to achieve overall project objectives. You can read it again. It's to identify obstacles and control them or combat them. It's to identify obstacles before a project is actually started or built. And we have to reduce errors, we have to reduce delays, and we have to reduce cost overruns. Someone defines constructivity as optimal use of construction knowledge and an experience in planning, designing, procurement, and field operation. So you can say it's kind of APC activity. And to achieve overall project objectives, constructibility is a term. This term defines the ease and efficiency with which structures can be built. Term constructability defines ease and efficiency with which structures can be built. More constructible a structure is, more economical it would be. Constructability is in part a reflection of quality of design documents. Important point is constructability is in part a reflection of quality of design documents. That is, if design documents are difficult to understand and interpret, project be difficult to build. So here is a question to designs. Maybe terms, so you can say extent to which design of building facilitates ease of construction subject to overall requirements for completed building, which is called the Syria. Effective and timely integration of construction knowledge. Effective and timely integration of construction knowledge into conceptual planning. Conceptual planning, design, construction, and field operations of a project to achieve overall project objectives in best possible time and accuracy at most cost-effective levels. Integration of construction knowledge in project delivery and balancing various project and environmental constraints to achieve project goals and building performance at optimal levels. What are the principles of that? Let's say there are 12 principles. It says 12. Let us see what it says. Not necessarily it should be 12. Which are mapped on procurement process. There are 12 principles of constructability which are mapped onto procurement process. It says integration, construction knowledge, integration, construction knowledge, team skills, corporate objectives, available resources, external factors, program, construction methodology, accessibility, specifications, construction innovation. Harm in saving that. What's wrong with that? Let's save this also. We can say MS, we can save in MS, no problem. We can say is construction, of course, constructability, Wikipedia. So let's save it. Let's save it as it is. Alright. So these points we consider, and we can now, because this is just 2 points, we have to understand that. Now we'll go to other one here. It says in this, of course, it would say something. There's no other than this. There's nothing as such. Let us say if we can do something. Main page contents, current events, What contents is this? Let's see what contents are. These are contents, contents, feature contents, main subject classification. Oh no, that's not that. Contents, current events, contribute. No, I think this is not related to this one. Let me see, in this I can get something, I can cut anything. Let's go to some other page and find what in these principles mean. I say, let's say something else. Construct Wikipedia this also. Now, what is meaning of constructability? Let us see that. What's meaning of constructability here? Constructability, a term used in construction industry and not fully understood, is integration of construction expertise and knowledge into design phase or pre-construction of project. What does constructability mean? Again, this is the question. So, first it says in this, people ask what's meaning of construction, because constructability is a term used in construction industry and not fully understood well. Well, what does it mean? The question is that, what does constructability mean? It says something, it's not opening, I think. There's some problem in this. I should open, it's not opening well. But what does it mean? So I think I have to remove this, no waste of time. Now, definition net. What is constructability meaning? Leave it. Let us say, what does constructability mean? Let us see if I kept this open. Constructability is a project technique to review construction process. So this is their definitions. Let us say this is a site of definitions.net. Definition for constructability. Well, it says constructability. It says I think only some information, not full. So let us see what it says. Constructability is a project management technique, is a project organization technique. It says constructability is a project organization technique to review construction processes from start to finish during pre-construction phase. So it's same as before. Is to identify obstacles before a project is actually built, or to reduce or prevent errors, delays, and cost overruns. The same thing has gone there. Also, constructability defines ease and efficiency with which structures can be built. More constructible a structure is, more economical it shall be. Constructability is a part, a reflection of quality of design documents. So it's a very important point. Construction is in part, constructability is in part a reflection of quality of design documents. That's if design documents are difficult to understand and interpret, project shall be difficult to build. Term refers to the extent to which design of building facilitates ease of construction. So it's an important point here. Design documents are difficult to understand, interpret, project difficult to build. Term refers to extent to which design of building facilitates ease of construction. Subject to overall requirements for completed building. Subject to overall requirements for completed building. Effectiveness or effective and timely integration of construction knowledge into conceptual planning, design, construction, and field operation of a project to achieve overall project objectives in best possible time and accuracy at most effective levels. So this is almost same, and there is no further explanation of constructible, that constructible. Okay, that's different language. I will go back to somewhere else. I don't think anything is copied here. Let's see. This was definitions net. Now I think it was Film Dictionary. What does constructability mean? That's another one. Constructability, an overview. Let us say sciencedirect.com. What does it say? Constructability, a design for constructability is a design to facilitate construction, taking account of workers' qualifications, capabilities and safety, environmental conditions, interface between equipment and workers. Now LNG project management, then it is process designs. Let's see what it says. It says that, let's see, for LNG project management, development, you guys are developing a project constructivity program. What it says about that? It says a constructability program can be developed to outline and document project organization team's policy regarding constructability. This should consider minimum criteria required for defining constructability, objectives, general resources, roles, and responsibilities involved, and a feedback mechanism by which contribution of program might be assessed. How many pages are there? I think I should copy this for our reference. It's a good one if you understand that, and there are long, so I try to take it for us for time being, and there may be a chapter. I'm not going to say chapter, just a vision. If each chapter will pre-project construction, program schedule, and okay, every chapter will see chapter later on. Let us now have view of this printed view. Information is good if you have just information as far as this coordination is concerned. It's very important point as far as coordination is concerned. Let's see what does work. I'm just trying to help you to understand more. I also understand more myself this way. I have got long experience, but yet learning has no experience, no limits. We can learn a lot. In the stage of 68 running, I want to learn more. What's the problem with that? What people think we should know. It's not that knowledge I'm getting, but it's a kind of information provision we have. So we can, I just skip it, save now, save as, and so that you can name us. I'll put save as, and it is save constructivity in overview. All right, let's say save like this. Now I'll go and say constructivity. Says about this, what does it mean by that? Let's think of the constructivity. Says it is, I think you're getting this now. You're getting this file. A design for you may say a design for constructivity is a design to facilitate construction, taking account of workers' qualifications, capabilities, and safety, environmental conditions, and interfaces between equipment and workers. And we have a handbook of the global related terms. Leave it an LNG project organization, and that's what it says. LNG is developing a project constructability program. How to make a constructability program? A constructable or constructability program can be developed to outline or document project management or organization team's policy regarding constructability. Should consider minimum criteria required for defining constructability objectives, and what's that? General resources, roles, and responsibilities. That's general resources, roles, and responsibilities involved, and a fresh feedback mechanism by which contribution of program might be assessed. A constructability program should include at least following. What's that? Clearly define and where possible quantified corporate objectives. It says clearly define and where possible quantified corporate objectives. Constructability organization chart defining roles and responsibilities. Constructability plans and implementation guidelines. Methodology for key performance indicators, KPI. Key performance indicators. Key performance indicators, measurement and verification. So methodology for key performance indicators are, we have to see analysis of KPI, that is key performance indicator, analysis of these KPI and interpretation to provide project performance benchmarking, procedure for capturing feedback and learning outcomes, and of course constructability tools which forms agendas, checklists and workshops, and we can say issues and change resolutions, a methodology. We have milestones for constructability workshops, overview of a typical constructability program, timeline is shown now. So we have here constructability program schedule, says starts with evaluation. Then we have to define and we have to detailed design. We have detailed design. We have to conduct feasibility studies, preliminary engineering, detailed design. Have then some evaluation, visual studies, and you can say concept constructive workshops and reviews, and front-end engineering design. After preliminary engineering design, and then we have detailed designs, drawings, P&ID, requisitions, manuals, long lead items, long procurement, and this is in preliminary design of the front engineering design, and the design documents. And then here is concept, is studies, concept, constructible, and workshop, and review, risk register, document design, then concept selection, project constructible plans, constructability, input and assistance to project planning. Now, what this says, a project construction kicks off. Most significant constructability, can say says a constructability program, as we call developing a project constructability program. That's our title. Other title, let us see what titles are. This is development. No, it's developing a project construct program. And we have here. Just let me move it, otherwise it's not moving. That's what's the problem here. Let's see, the problem should not appear here. And I think. Okay, developing a project constructibility program. We have project constructibility program schedule. We have such and training of PVC structural systems. It's not that. And we have here constructability VIP. Constructibility VIP is, we say, then there's prefabrication of substructure and construction issues. So we can go back and see how to do. We have these points to clearly comprehend, clearly defined. Let me see again what points it says. Clearly defined, and what inclusions are here on LNG project time, which says it is what says should include at least follows: clearly defined and where possible quantified corporate objective. Constructability organization chart defining roles and responsibilities. The important point is roles and responsibilities in constructability plans and implementation guidelines. Methodology for key performance indicator, that is KPI, key performance indicators, measurement and verification. Analysis of KPI and this key performance indicator. We can say constructability organization chart, defining roles and responsibilities, and also constructability plans and implementation guidelines, methodology for key performance indicator, KPI, measurement and verification, analysis of key performance indicators and interpretation to provide project performance briefing. Analysis of key performance indicator, we have to understand that also very clearly. Analysis of key performance indicator and interpretation to provide project performance benchmarking, procedures for capturing feedback and learning outcomes, constructability tools, forms, agents, agendas, checklists and workshops, issue and change resolution methodology, milestones for constructable workshop, an overview of typical constructability program timeline is known as here, as we said before also, project constructability program and schedules, evaluation, definition, detailed design. In evaluation, we can say feasibility studies, concept, constructability workshops and review. And we have definitions like preliminary engineering, and then we have front-end engineering designs, and we have design documents. Then design documents, we have detailed design, drawing, PNIDs, and you can say requisitions, as well as we may say manuals, long lead items, comprehensive constructive reviews. And then we have the technical definition, this execution one. constructability input and assistance to project planning. And here's technical distance at left indicating arrow and definition right indicating arrow. A project construction kickoff. Project construction kickoff. I just put on switch. Oh, my battery source is disturbing. No issue to you. You enjoy your construction talk. It continues as usual. And it is here now. Project construction kickoff. Most significant constructability issue it is. Should have already been implemented. A project construction kickoff most significant constructability issue, that is kickoff, or in implementing the construction plans. At this point of kickoff, a constructability review follow up action register is often used to document actions and responsibilities that have been gathered from formal constructability reviews. Ongoing thorough through planning and detailed design phases. A project constructability coordinator should be responsible. A project constructability coordinator should be responsible for working with each organizer or leader or supervisor to ensure items are closed out and properly documented as project execution plan. Are documented as project execution plan progresses. Project leader or its designate should be responsible for ensuring lessons project leader or its designate should be responsible for ensuring lessons are captured from constructability reviews and discussed with project constructability coordinators for dissemination to other project teams. In this way, constructability methodology facilitates an ongoing learning and improvement process built into project strategies, incorporated into agreed amendments to project charter. Constructability, if properly defined, structured and used, should ensure that construction knowledge and experience is used as early as possible in planning and design process to ensure design and implementation plan practicality and cost effectiveness. Constructability is simply utilization of construction knowledge. Experience and efficiency in a structured and systematic way throughout design and execution planning stages of facilities. Project constructability issue touch on all aspects of project execution, including safety, scheduling, detailed design, procurement, material equipment, delivery, contracting, temporary facilities, infrastructure needs, commissioning, and project organization, team organization, you can say. Now, what we say here, research and training in ABC structural system. Let us say the primary object of ABP includes constructability, erection, serviceability, durability, maintainability, inspectability, economy, and aesthetics. Develop modern codes and construction specifications, Construction mistakes, ship collision. Let us go back and see how this happen. Let's first do this process design. Let us say constructively VIP, as we said here, indicative factors. We said VIP, that's KPIs VIP. Construction ability VIP is facilitated systematic implementation. Facilities systematic implementation of latest engineering, procurement, and construction concepts, and lessons learned consistent with facilities operations and maintenance requirements to ensure enhanced construction safety, scope, cost, schedule, and quality. VIP involves, you can say, VIP involves planning, design, procurement, fabrication, installation to achieve best overall project safety record, lowest installed cost, and shortest reasonable schedule. Constructively helps to account for construction options and requirements during design, thus reducing rework and delaying in construction and startup. So VIP here is prefabrication of substructure and construction issues, and you can say long-term project delivery goals. All contracting agencies should have a project delivery or toolbox including following: design, build, construction manager risk, innovative contracting method called construction manager at risk. Is a delivery method that offers number of time and cost saving advantages with CMAR, that is construction manager at risk. Certain girders might be better suited to construction, where advantages in cost time construction and reduced congestion due to elimination of false work. Success of a recently completed precast girder system has been cited. So construction manager general risks depends, and also CMAR performs constructability reviews and offers value engineering suggestions. This early coordination fosters collaboration and focuses entire team on findings best solutions for construction projects. Also exists an effort to coordinate all subcontract bids and determine a guaranteed maximum price for construction. As with all services, construction manager risk process can customize a solution that includes some or all of responsibilities generally associated with risks. Advice and consultation on all aspects of planning risk associated with risks. Advice and consultation says in this sentence, as with all services, CMR process can customize a solution that includes some or all of responsibilities generally associated with risk. Advice and consultations on all aspects of planning, management of design and construction phases, establishment of parametric for quality, cost, and time, provision of constructability reviews and cost analysis, preparation of bid packages, preparation of conceptual and detailed estimates, development of phasing and sequence planning, ensuring constructability of design while minimizing cost and schedule, preparation of overall project schedule and provisions of periodic detailed updates, establishment and maintenance of quality control standards, guaranteeing construction costs, serving as general contractor. So these are books, concerned with. It says books I'm not interested in this. Just why costs is, you can say, let's say research and training structure system. Something long span bridges limit plans. All this will take. That is we are interested in constructability access. Likewise, we can say. So we'll go back and see, and sometimes also take into this. Okay, and we'll go to what is constructability. Let me put this page off. And so we say now how we move forward. Now we can see what is constructability. QC library constructability is project management constructability definition, law insider. I don't think there's much more available here. Same general. Let me see if I can find something more. Constructability, CII, construction industries. CII, let us see what it says. CII is something, let me see what it says. Certainly something different. It says no. Let's see. Constructability, what is CII? I don't think it's giving something better, just some, no, leave it. It's only nothing very important. Then constructability, meaning, origin, leave it. What is constructability review? What is buildability in construction? And buildability in construction 2019, integrating construction structural designs, integrity constructability into conceptual structural designs. Let's say first of all what's buildability in construction. Just give anything, we'll see what's buildability in construction. There's something buildability. Oh my god, subscription I can't give, it's a waste of time. Constructability review, constructability definitions, meaning, an overall overview of constructability. Now constructability from nothing else, PDF. An overview of constructionability, a management tool. Let us say, what does this says? Maybe something good. It's a full text PDF. It doesn't give anything. Overview is a management of tool for architects. Introduction is giving something. Let's see if it can find something. Let me see. I can. It's a book actually. Download full text PDF. Let us see. Sharmin Khan. What it says. Sharmin Khan. Let's say it does or not. It does or not. I'll think. I'll download this and we'll discuss this long way. It's PDF and page 16. It is view of constructability management tool for architects. And let's say I think it's something. It's something maybe. An overview of constructability. The management tool for architects is by Sharmin Khan, Department of Architecture, Faculty of Engineering and Technology, Aligarh Muslim University, Aligarh, India. So it is our book. It says construction industry being one of biggest industry involved in many issues. One of such issue is constructability, which is a management tool to optimize construction knowledge and experience on various stages of project to achieve overall objectives, evolving as one of most important considerations for participants of project, client, architect, designer, constructor, contractor, consultant. This is a paper actually, is an overview of issues covered in constructionability concepts, also discussed some implementation of concepts. So introduction is here. Then energy consumption in construction industries. We have the management scenario in construction industry, project phases and project delays. Then we have here, well, this is theoretical actually. Extreme weather concept constructability, and then it is you can say constructability enhancement concepts during conceptual planning phase, and such concepts are given, which is about concepts. It is giving I think about 23 concepts. Then we have to major issues of constructabilities. I think very elementary. This is integration, and we have to go through so coordination and bidding process, construction driven schedule, simplification of designs, We have standardizations of element. We have prefabrication, specification, encouragement, etc. Accessible to site. Extreme adverse weather conditions, appraise recycling, past lessons learned, waste management, availability of resources, employment of advanced information technology, awareness about constructability, benefits of constructability, and barriers to constructability, and we can say references, of course, because what conclusion says, an overview of concept of constructability has been presented in this paper, which importance with respect to savings in overall economy of country have been highlighted. 16 major issues of constructability have been identified as integration. What are these? Integration, coordination, bidding process, construction-driven schedule, simplification of design, standardization of element, prefabrication, accessibility to site, adverse weather conditions, specifications, encouragement to innovations, past lessons learned, and reviews, availability of resources, appraising recycling, waste management, employment of advanced information technology, barriers need be taken care of, and hurdles passed for successful implementation of concept. Early implementation of constructability principles as management tool, and this recommended to make projects successful and achieve better results in terms of better design, improved site management tools, and enhance project quality. Tool is also expected to save money and resources, as the construction industry is responsible for 40% energy consumption and 50% waste generation. Okay, this is a conclusion, theoretical conclusion, not practical one. There are references, we go up and see how it is working. That's the main point we can see. Here we can say some barriers to constructability. CI has classified barriers to constructability onto various categories as general barrier, owner barrier, designer barrier, contractor barrier. They can be all this terminology used like this. Something you can say. Let's go. The benefits of what benefits says. Long time back, construction projects were single-handed by master builder, who used to take care of design as well as construction activities for a project. There was huge amount of integration in this process, as design and construction considerations were very well taken care of. Early decisions regarding construction materials and methods could improve design and increase the buildability of project. With increase in specialization in construction industry, design and construction activities got separated considerably. With lesser concern and knowledge about each other's areas of specialization, buildability got affected, and need to you can say reassure. The problem is these people need to reassure and integrate two processes of design and construction, brought into picture concept of constructability. Constructability is a value management tool developed as an attempt to bring closer design and construction activities, I don't accept well, to level of integration once achieved. Okay. Russell have also discussed in their paper. Okay, the point is not interested one. Okay, what points actually are important? Barriers to constructability, what these barriers are. It says complacency with status quo. What is it? What status quo? This is CII 1987 has classified barriers to constructability into various categories as general barriers, owner barrier, design barrier, contractor barrier. They can be listed as follows. General barrier, these are here. Increase, what's that general barrier? Let us see. Complacency with the status quo. This is just another program. Right people are not available. And discontinuity of key project team personnel, no documentation of lessons learned, failure to search out problems and opportunities, and owner barriers, lack of awareness of benefits, concepts, perception that constructability delays project schedule, reluctance to invest additional money or effort in early project stages, lack of genuine commitment, distinctly separate design management and construction management operations, lack of construction experience, lack of team building or partnering, disregard of constructability in selecting contractors and consultants, contracting difficulties in defining constructability scope, misdirected design objectives and performance measure, lack of financial incentive for designer, gold-plated standard specifications, limitations of lump sum competitive contracting, unreceptive to contractor innovation, and design barriers perception that they have considered it, lack of awareness of benefits, concepts, lack of construction experience, qualified personnel, setting company goals over project goals, lack of awareness of construction technologies, lack of mutual respect between designers and constructors, perception of this increased designer liability, construction input is requested too late to be of value. Benefits of constructability says increased job satisfaction, provision of feedback for future projects, earlier client occupation, efficient management of waste problems, improved site management, better communication, fewer delays and disruption, increased project performance, more effective construction planning, better design, minimize contract variation orders and dispute, increase owner satisfaction, enhances partnering and trust among project team, reduces project cost, reduces project duration, enhances project quality. This says benefits. Now, what barrier contracts? Barrier reluctance of field personnel to offer pre-construction advice. This contractor's barrier says reluctance of field personnel to offer pre-construction advice, poor time lines of input, poor communication skills, lack of involvement in tool and equipment development, and when there's something very cannot say. Actually, let me copy this also better, because we cannot be, as PDF can be copied. No, I think it can be copied. What's wrong with that? Save as, let me see, save as, and I can save as if it's possible, because it's PDF and it can be saved. It can be saved in method statements, I can say. Let's go to save method statements just for real. So this is constructability, not constructability. Let me write constructability. So we'll take it as usual now. Let's say how does it work. I saved it just for future reference. I'll discuss later after going through this. What does it say? Let's go to find something else if I can get on this. This was this one, Sharmin Khan's Shaitis was important. Let's go to buildability in construction, design building, Wikipedia. No, it's not Wikipedia. Yeah. Buildability in construction, that's 20. Let's see what says. Buildability in construction is the main thing. This is buildability. I'm going to see. Buildability is also, I think it's better to copy this as well. This is, buildability is a pre-construction exercise. It says this is designbuilding.co.uk. Buildability is a pre-construction exercise that assesses the designs from perspective of those that will manufacture, install components and carry out construction works. It should not be confused with value engineering, which is used to solve problems and identify and eliminate unwanted costs. Though some processes are common to both activities. In very broad terms, buildability should assess elements of design in relation to achieving desired final quality, meeting program requirements, de-risking perceived problems, and achieving optimum value for money. Buildability involves careful study and considerations of sequence of activities and that take place and off-site, taking into account state of building and its weatherproof environment at whatever time, dimensional criteria, setting out and space allowances, use of plant and equipment to save labor and time and prevent possible damage, practicality, flexibility and tolerances, standardization of components and processes, reduction in complexity to shorten learning curves, identification of appropriate suppliers, prefabrication opportunities, packaging and works and allocation of scope in relation to trade and specialist contractors, context, ease and order of interface, connections and abutments, installations and maintenance access arrangements including long-term replacement, health and safety, temporary works such as propping, facade retention, retaining facilities and trench support, crane support, formwork, false work and scaffolding including gantries, susceptibility to damage and protective procedures in transit and in situ, weight and lifting requirements, uploading operations, spare parts and storage and waste management. Advances in computer-aided design, computer-aided manufacturing, as well as introduction of building information modeling are immensely helpful in visualizing many aspects of buildability. However, availability of technology doesn't remove need for engaging practitioners who have hard-won experience and awareness of site practicalities and potential pitfalls. Contractors are often best placed to advise on issue of buildability and some procurement methods such as construction management, management of contracting and design build, allow early appointment of contractors to offer advice and feedback on design proposals, and we can say read the articles. Okay, I will see later on what we can say. Does it help? Point is that does it help what we have noted in? Is all I can say. Just keep this in terms of actually, there are many points. Just CDM planning period, construction manager, construction phase, not that much. Well, I see buildability. If you say here buildability, what it says in this buildability has something or not. I have to see. We're saying that we have gone through the same things, buildability, nothing specific here. So buildability okay is the one designbuild.com same, so we can just print it out and take for our reference. Nothing else. You can just will later on concentrate on this. For timing, I take this now as a result of search, so I don't find more time again. We will go back to this in meanwhile. I'm just copying it for record so that we can discuss it. It comes back to us and we can discuss it. And this buildability, I guess constructability, I write, so easy to find constructability. So you can say constructability, I put in there so I can find it easily. So there's no issue here. I can say we've gone through this, it's okay. Let's find this way and find here. In fact, we go back to something else. As one construction manager, value management. What's value management? Let's see what's value management. Is a very important point here. Value management, that says value management, building designs, construction, history of development. It says value management, VM, and value engineering, VE, are techniques concerned with defining, maximizing, and achieving value for money. These are systematic team-based collaborative approaches initially pioneered in the United States during Second World War. Leave it behind. At initial stages of project, value management provides an exceptionally powerful tool to explore project objectives. Okay, leave it aside, so nothing, just leave it. I don't think it's very important. Now let's go back to our own system and we say now this constructed phase. Now I go back and we'll see. I'll close this and go back to our own. That's the temperature is important now at this moment. And we can tolerate this or no. It's 620 already and I have not much time, 11 degrees, so it's increased little. Okay, so increase a little and let me see what does this mean. So let's go back to our time and we now come back to our own statement, and that says stock in sequence technology took a lot of time. Sequence technology is a dominant issue in current advanced technology application scenario, which of course lacks in training at first level of education. I didn't find anything specific in these talks I did, and these references I tried to search on Google. I didn't find anything very practical except some theoretical answers that should be kept in mind that engineering is a factual world, no fiction can be successful, which means that just talking is not enough, and deserves practical work. And for me, a foresight requirements a lot of professional maturity is essential to comprehend the whole issue that relates to works to be carried out by various either agencies or parties involved in every project from conception stage to design stage to construction stage and then final to delivery stage. And such activity entitlement can be described in heading forms such to be indexed in introduction of project planning, explanation, planning classes, entire design involving all disciplines, pertinent all branches of jobs, including engineering whatsoever, detailed designs for project functional requirements for purpose of further documentation that will be required for meeting objectives, information of formal contractors, working documents, and then you can say quantification leading to various bills of quantities, preparation, specifications, all these points are there. You can say this is a very important phase. We can point 76 here. Let's see what it says once again. We say it's because of 75 and 75 says for meeting of foresight requirements of constructability. It says constructability is that's also the total concept of constructability. Buildability must be taken care of during also designs and respective coordination, which if ignored could mar smooth execution possibility of project work, and therefore constructability is very dominant issue in current advanced technology applications in this scenario, which of course lacks in training at first level of education. It should be kept in mind that engineering is a factual world and fiction can be successful. So what are these points? We can point 76 such activities and entitled what activities actually we have to refer to. This can be described as heading form. We are just giving heading explanations. Explicitly give analysis of project planning and explanations of planning classes. Entire design involving all disciplines pertinent to all branches of job, including engineering whatsoever, detailed designing per project functional requirements for purpose of further documentation that may be required for meeting objectives of formation of formal contracts or working documents, quantification leading to various bills of quantities preparation, specification preparation which could be general as well as project related specifically, particularly as well as manufacturers related procedures, processing comprehensive packages of bidding documents and shortlisting possible project with experienced bidders and processing entire bidding, leading to selection of contractors after having conducted thorough scrutiny of received bid documents passed through professional competition, and furthering if required conducting negotiations between based on value added bids and also received an alternative bid in formal declaration of permanent contractor, which could be either in construction status or in EPC status depending on requirements. 77 is foregoing major paragraphs contents give of fulfill pre-construction or pre-project execution requirements, which are of course very cumbersome since all involved activities are office oriented, but import heavy requirements of professional working experience and professional pragmatism for a successful impending contracted document is based on bid documentation, and for sure RFOs they included works activities amount to involvement of engineering and coordination on equal basis. Because if one is missed, others shall also miss, which in criticality must be considered seriously for smooth, for reliable documentation, for reliable working or execution of project works. It's again refreshed that the conducting multidisciplinary coordination from involved branches of various engineering that must be depending on project nature shall always be a must for final detailing of the engineering solutions and not just working on an isolated solution for each discipline. This requirement is often missed by many juniors, the budding professionals, the lack of project experience, but once one gets itself certain project delivered then considerable lot of learning is attained. This is an only reason that after having undergone few years of working experience on certain projects, One can call self a trainer to oneself and then trainers towards others, which wealth earns one's self-confidence, whereafter such confidence acts as one of competency potentials, and each and every such competency or competencies counts while considering professional attainments, marking as a part of continuous professional development, CPD we can say. And of course, in such useful and engineering grooming up situations that makes projects to act like field universities through to no academic short-term title is conferred yet. There is no alternative to replace such reliable training from elsewhere, because such project-related organization equips incumbent professionals with certain permanent knowledge along with sharing responsibilities, and such chain continues throughout work area of professionals. Since this page is exclusively related to coordination activities that are always involved in engineering decision making, without which support the progress can be held. Such a requirement imports a very important significance and necessary of certain reliable professionals having multifaceted theoretical and practical experience on various callings, and even if one has deficiency in certain discipline documents, reading would make up that deficiency. It's also a certain fact that coordination is an individual circuitry oriented without requiring any interruption to enable incumbent coordinator to concentrate continuously for whatever issue until resolution reaches for clarification, confirmation, and for certain possible proposition whatsoever unit suits best in project interest. Many documents can be used and are used in many projects, such as indicated below, but more, if so required, can be added, whereas most people associate criteria for works with drawings and specifications. Although these are likely to be most significant sources of information, nevertheless, there are other, and it's important to consider all such documents. Drawings and specifications often refer to and require compliance with other documentations. Now, I will go this way. Let us say I'll just give a brief on this to you. You can read it for time being. We'll back in a couple of minutes. Meanwhile, you can say, let's see what to do with that. I'll be back in a couple of minutes, so you can have this back. continue with that. Sorry for a little late. We have to take care of this now and conclude this. In fact, this talk, which is very important for everybody, we have to take it into consideration and put in all this coordination issue, which is very important for everybody. And we have to move to a level we never moved to. As I said, that we included also buildings management system. Buildings management system, which is very important for current buildings. Building management system means building management of services and precautionary measures and protective measures that are permitted, that are required in that. And also we can say that whatever is there, I've not gone to that one yet, but I have learned that this is when there is fire breakout in buildings, how we have to take care of that, or when there is some other emergency, how to take care of that, how to organize, how to manage, how to worry about that. All that are required in the system, management system. And when you say management system, this means we have to understand what we are talking of. It's not simply management in addition to services. That's also a part of services, but that is different type of services. Loss prevention services. Loss prevention services means we have to take care of automation of all services, automatic connections of electrical, mechanical, plumbing, of course lift services, fire services. Everything should move in unison. I will take care of that in coming time, and of course I'm working with that. It's very important one, not so easy to understand just in one moment. We have to be very clear about that, and we have to be clear about everything as we discuss, and we have to discuss many times, and it cannot be just concluded in one go. We have to be very specific about that, particularly in gas services. We have to take care of that. We have to take care of that one, how gas services work, how we have to handle, and how, for example, it is, we can say building management. Let us see building management, what is that? There's a definition of that. Building control, building management system. We say building management system, what that is that a building management system, otherwise known as building automation system, is a computer-based control system installed in buildings that controls and monitors building mechanical and electrical equipment such as ventilation, lighting, power system, fire system, and security systems. This is basic definitions of systems. And what is that actually? You have to understand that. Otherwise you can say a building management system consists of software and hardware. Software program usually configured in hierarchical manner that can be proprietary, using such protocols as C-bus is one, Profibus, and so on. Vendors are also producing a BMS that integrates the use of internet protocols and often standards such as DeviceNet, SOAP, XL, BSET, Linework, etc., etc. Building management systems are most commonly implemented in large projects with extensive mechanical, HVAC, and electrical systems. Systems linked to BMS typically represent 40% of a building's energy usage. If lighting is included, this number approaches to 70%. BMS systems are a critical component to management energy demand. Improperly configured BMS systems are believed to account for 20% of building energy uses, or approximately 8% of total energy uses in the United States. In addition to controlling building internal environment, BMS systems are sometimes linked to access controls such as turnstiles and access doors, controlling its all access and egress to building. Other systems such as closed circuit television and motion detectors, fire alarm systems, and elevators are also sometimes linked to a BMS for monitoring. In case a fire is detected, only fire alarm panel could close damper all ventilation to stop smoke spreading and shut down air handlers. So building management system also many disaster responses mechanisms. We have to take care of that one. And building management system, is such a system that we have to take care of that very cleanly, barely. We cannot just move on. We cannot just move on, and we have to think of that in proper way. It is many systems that helps us do it in a proper way, in such a way that we have no other point of worry in that. If we take control of building management system, we have to think of that later on. Let's not just copy this one to my page for purpose of conducting research on that. And also we have to see we have to think of that. For example, CBus, I'm talking of what is CBus, and we can say CBus communication protocol, and we can say that one is very important for us, and we can take that into considerations, and we'll do that. In fact, we'll do that one here. I just thought it CBus is what I thought, and we have to see also what is otherwise should be. Means we have to take references. So CBus, for example, it is, and I'm taking also here something like that, something like that. We can say also Profibus, and Profibus, what is that? Profibus, is a process. We can say just references I'm taking to use in my talks. So that's this one I'm taking, for example, this one, and also we'll discuss this later on. We cannot go into details of that, but just in a way to refer. So it is a reference only, so I close it now for time being, because it's going to be 3 hours over, and we'll take care of this later on. I'll closing this file also for saying it. See later on also after it. Now it's already 3 o'clock. I'm going to close it now for time being, and let's better discuss the early. You can say it's my email. You can suraj_engineer@yahoo.co.uk, and also my certification of chartered professional engineer and certification of quality file, and this is a condition file. She's under consultation now. I'll take a leave for time being. It's okay, 3 hours over. I think we got happiness with this, got some clarity of what I'm talking with. It's important to talk of in details, but sometimes it takes time. You have to understand what's management, organization, as well as buildability, constructability. Took a lot of time to do. It's very important because I was in mind. And we'll go to other issues also next time. We'll search out about inert and gas system, FM200 system. We'll take into here. Previously also we talked, but it's better to talk with constructability. Or you can say, your building management is involved. It's very important one for this point of view. I'll say, okay, now time to close in. It's very much important to understand what we have discussed so far. Discuss something is important one. Yeah, and we have gone through this. We can say that we have gone through these files, which are, of course, very importantly here done. And I close such files now. I will seek, and of course, all the file close. I close this file as well, and see how does it happen, this file, which is ultimately here. And now we have to take your permission. This 3 hours already over, and we can say constructability is an issue, and we discussed that one here, overview of construction management for architects, and close this here as well. And now we can say, okay, fine, it happens. I close it.